Professor is on a mission to solve one of the greatest mysteries of space. Tonight, he shows WBZ's Mike Sullivan his team's latest discovery that could help get us one step closer to understanding whether we have neighbors.
When telescopes trained their lenses on the distant traveler known as 3I Atlas, astronomers expected the object to continue its slow and silent journey through the dark canvas of interstellar space. Instead, what they observed stunned even the most seasoned experts. The elongated body of the interstellar wanderer fractured into two distinct segments, as if some hidden internal pressure or unseen external influence had pulled it apart. Harvard researchers working alongside NASA teams monitoring its trajectory confirmed that the split was real and not an illusion of instrumentation or a temporary dust event. A single entity had become two, and the scientific community was left grappling with questions that seemed to multiply faster than answers could be found. Before we start, smash the like and subscribe buttons for more updates. The drama of this event lies in the nature of 3I Atlas itself. Like its more famous predecessors, it is not a native of our solar system. It originated from elsewhere in the galaxy, flung across interstellar distances before fate carried it into the gravitational reach of the sun. Objects of this kind are exceedingly rare, and each one provides a fleeting opportunity to study material from beyond the familiar cradle of our planetary neighborhood. For such a body to undergo a sudden transformation during its brief visit is an anomaly that shifts the narrative from simple observation into a deeper mystery. When Harvard and NASA jointly verified the bifurcation, the weight of the confirmation could not be overstated. These institutions are known for rigorous checks and skepticism before making claims of such magnitude. What the astronomers reported was not a speculative interpretation, but a clear, consistent signal across multiple observatories and instruments. The object had split, and the fracture lines were evident in reflected sunlight. To say this was unexpected would be to diminish the profound surprise that rippled through scientific circles. The mechanics of how a massive body of rock and ice from deep space could fracture so suddenly are difficult to reconcile. Unlike comets within the solar system, which can fragment under solar heating, interstellar objects often arrive hardened by eons of exposure to cosmic radiation and the chill of space. They are not delicate snowballs, but time-worn relics of ancient stellar nurseries. 3I Atlas was thought to belong to this hardy class, a voyager resistant to small perturbations. Its splitting therefore points to processes not fully understood. Did it conceal volatile materials beneath a crust that suddenly vented under solar warmth? Was there a structural weakness dating back to its formation that finally gave way? Or was the break triggered by some external factor that astronomers have yet to perceive? Every possibility carries implications. If the fracture was caused by hidden volatiles, it means interstellar objects may not be as inert as long assumed. This would challenge prevailing models of their composition and history. If structural fragility was to blame, then their role as carriers of pristine galactic material could be more complex, as what reaches us may already be fragmented relics. And if the cause lies in some unrecognized force, gravitational tides, electromagnetic interactions, or even particle bombardment on a scale not yet measured, then the split of 3I Atlas may herald a new category of astrophysical phenomena. The geometry of the split itself fascinated observers. The two bodies did not scatter wildly apart as if repelled by an explosion, but drifted along similar trajectories, separated yet still kin. Their movements resembled siblings set adrift from the same origin, bound to diverge over time but unmistakably linked. This behavior suggested the break was not catastrophic in the sense of a violent detonation, but more akin to a quiet unspooling, a tearing of fabric rather than a shattering of stone. Such subtleties matter, for they hint at the forces at play and the timelines over which they acted. As Harvard's astrophysicists and NASA's mission scientists pieced together the data, the larger implications began to crystallize. The universe had handed them a puzzle without precedent. To witness an interstellar object splitting in real time was to stand at the edge of knowledge, staring at an event that no predictive model had anticipated. It was not merely a curiosity. It was a disruption of assumptions that would ripple into the way scientists conceive of planetary systems, stellar debris, and the transport of matter between stars. For the broader scientific community, the event underscored the fragility of certainty. Astronomy often deals with extrapolation, building theories on the basis of limited observation, extending patterns across cosmic scales. But when reality defies those patterns, it forces a reckoning. The split of 3I Atlas was one such reckoning. It reminded researchers that the cosmos still has the power to surprise, to confound, to reveal complexities that had lain hidden for billions of years. The implications stretch into astrobiology as well. If interstellar objects are not static husks, but dynamic bodies capable of internal activity or structural transformation, then their role in carrying organic compounds across the galaxy may be richer than assumed. A fracture could expose fresh surfaces to radiation, altering chemistry in ways that seed complexity. Pieces that break free may wander on divergent paths, potentially delivering materials to planetary systems far removed from their original trajectory. The splitting of 3I Atlas in this light is not merely an astrophysical oddity, but part of a galactic narrative about how matter and perhaps life's precursors travel. NASA's involvement lent another dimension: the practical challenge of tracking two interstellar fragments rather than one. Each fragment carries its own orbital path, requiring recalculations and adjustments in observation strategies. The ability to monitor them provides a laboratory in motion, a chance to compare twin bodies that share origin yet may evolve differently. Such natural experiments are priceless, offering a side-by-side study of cosmic siblings under nearly identical conditions. The excitement within Harvard's halls echoed the same thrill. Scholars there saw in the fracture an invitation to revisit fundamental questions about planetary formation, the stability of small bodies, and the behavior of matter in the harshest cosmic conditions. Their analyses, combined with NASA's wealth of observational power, forged a collaboration where science pushed into unexplored territory. No one yet could offer a satisfying explanation, but the shared mystery created momentum for new lines of inquiry. As telescopes worldwide joined the effort, the image of 3I Atlas splitting began to spread across both professional circles and the imagination of the public. There was something profoundly human about watching a singular object divide, echoing myths of duality and separation. Yet the scientific import remained central. This was not mythology but data, not symbolism but reality. Still, the awe it inspired showed how events in the cosmos resonate on both intellectual and emotional levels. The very name, 3I, denoting its place as the third recognized interstellar object to pass near us, now carries added significance. The catalog number once meant simple classification, but now it marks a milestone in astronomy's evolving story. Where once scientists thought to log another traveler, they now must record a transformation mid-journey. The chronicle of interstellar visitors has become richer, less predictable, more alive. The paradox at the heart of the event is that it offers both clarity and obscurity. Clarity, in that the split is undeniable, verified by institutions whose rigor is unmatched. Obscurity, in that the cause resists every explanation currently available. In this tension lies the essence of science, the interplay of what is seen and what remains hidden, the known and the unknown. 3I Atlas has become a symbol of that interplay, a reminder that discovery often begins with bewilderment. As days pass and observations accumulate, the two fragments continue their slow glide out of the solar system, destined to vanish into interstellar night. But the mark they leave behind is indelible. Scientists will be analyzing this split for decades, mining it for insights into material strength, compositional diversity, and galactic history. Harvard's careful data parsing, NASA's relentless tracking, and the global community's contributions ensure that the story of 3I Atlas will echo long after the fragments themselves are beyond sight. Even without aftermath or resolution, the moment itself stands complete. A cosmic traveler arrived, revealed its secret fracture, and reminded humanity of the limits of its knowledge. The universe once again demonstrated that its mysteries unfold not on our schedule but on their own, and that even a fleeting encounter with a shard of another star system can overturn what we thought we knew. The split of 3I Atlas is both an event and an invitation. An event in its undeniable reality, and an invitation to stretch the imagination, to reconsider the models, to open the door to questions not yet asked. The grandeur of the moment lies not just in its rarity, but in its depth. This was not a distant star exploding, not a galaxy colliding, but something small and quiet, a fragmenting rock against the void. Yet in its smallness it carried enormity, for it touched the boundaries of science itself. It is in such subtleties that the cosmos speaks loudest, not with cataclysm but with quiet, inexplicable gestures. Word by word, observation by observation, the chronicle of this split will take its place among the annals of astronomy. Scholars will return to it as a touchstone of the unexpected, a case study in humility before the cosmos. Harvard and NASA, by confirming what might otherwise have been dismissed as error or illusion, have ensured that the event is recorded with the weight it deserves. The mystery remains intact, but so too does the sense of wonder, the thrill of watching the universe act outside the bounds of prediction. And so 3I Atlas drifts on, not as one but as two, its divided form a symbol of the unknown forces that govern interstellar bodies. For those who watched it split, the memory endures. The sight of certainty giving way to mystery, of the cosmos reminding us that it is vaster, stranger, and more intricate than even the most careful models can contain. The announcement from Harvard and NASA that 3I Atlas had split into two was more than a piece of astronomical news. It was a seismic moment in the ongoing story of humanity's relationship with the cosmos. The sheer novelty of the event pushed observers to widen their perspective, to think not only about the mechanics of what had occurred, but also about the broader context in which such an anomaly might be situated. Every new detail amplified the magnitude of what was unfolding, and each observation invited deeper reflection about how little is known about the material traveling through interstellar space. At its most immediate level, the split of 3I Atlas forced a reconsideration of interstellar bodies themselves. For decades, astronomers had assumed that such wanderers were little more than inert chunks of rock and ice, drifting across stellar neighborhoods after being expelled from their original planetary systems. They were thought to be relics, survivors of processes that had long since concluded in distant places. But when 3I Atlas fractured, that narrative shifted. Suddenly, the interstellar visitor no longer appeared to be a silent relic, but a dynamic entity still capable of change. This transformed it from a fossil of the cosmos into a participant in it, subject to forces and processes that remain active even after unimaginable journeys across the galaxy. The detail that the two fragments continued on similar paths only added to the intrigue. Instead of scattering violently, their movement suggested a delicately balanced process had taken place. It was not chaos, but a strange measured division. This brought with it implications for stability and internal stress within such bodies. Perhaps interstellar objects carry reservoirs of tension, accumulated during their long voyage through cosmic radiation, stellar winds, and gravitational interactions. If so, the split of 3I Atlas might be understood as a release, a long-delayed expression of pressures written into its structure over eons. Theories began to proliferate in laboratories and observatories across the globe. One possibility that gained attention was that 3I Atlas had harbored deep reservoirs of frozen gases or volatile compounds, locked beneath a crust hardened by ages in the interstellar cold. As the object neared the sun, subtle heating could have reawakened those materials, causing sublimation or expansion that tore the body apart. But such an explanation was complicated by the fact that the fracture did not resemble the violent disruptions typical of solar system comets. Rather than fragmenting into a cloud of dust and shards, 3I Atlas remained remarkably coherent, producing two large pieces instead of countless smaller ones. Another speculation turned toward the idea of mechanical weakness seeded during the object's birth. Perhaps 3I Atlas had never been truly solid, but instead a conglomerate of loosely bound material, similar to rubble pile asteroids known in our own system. In such a scenario, the stresses of interstellar travel may have held the body together until gravitational tides near the sun gently pried it apart. If true, this would indicate that rubble pile structures are not confined to solar system formation, but are a common result of planetary development across the galaxy. Some researchers dared to wonder whether 3I Atlas encountered an external force not yet fully understood. Cosmic rays, charged particles, or magnetic interactions on interstellar scales could have imposed unseen effects on its integrity. There is also the subtle possibility of tidal resonances, gravitational nudges not only from the sun, but from the combined influence of planets, moons, and even other passing bodies. In this sense, the split may have been a response to a chorus of forces acting in concert rather than a single identifiable trigger. Harvard's contribution to the analysis was especially focused on the data gathered in the days before and after the split. Their instruments captured variations in light curves, the flickering pattern of brightness that betrayed the rotation and changing orientation of the two fragments. These patterns, while complex, offered hints about the shape, spin, and relative surface properties of the bodies. Meanwhile, NASA's spaceborne observatories supplied infrared and ultraviolet measurements, helping scientists determine whether any significant outgassing or dust release had accompanied the fracture. To their surprise, there was little evidence of a dramatic discharge. The division had been quiet, restrained, and nearly graceful in its subtlety. This calmness set 3I Atlas apart from familiar breakups, such as those seen in comets like Shoemaker-Levy 9 or Comet 73P/Schwassmann-Wachmann, whose fragmentations were spectacular, messy, and visually dramatic. Here, in contrast, was an interstellar visitor dividing itself with almost surgical precision, as if some hidden boundary within it had been waiting for the right moment to yield. Such behavior struck many scientists as alien, not in the sense of artificiality, but in the sense of being utterly outside the norms established by solar system precedents. Beyond the scientific details, the event stirred philosophical reflection about how humanity perceives change and permanence in the universe. For centuries, people imagined the heavens as immutable, a backdrop against which the drama of earthly life unfolded. Modern astronomy has revealed the sky to be restless, stars dying, galaxies colliding, planets forming, yet still there was a sense that the small wanderers, the comets and asteroids, were enduring survivors, consistent markers of cosmic time. The split of 3I Atlas punctured that assumption, demonstrating that even these seemingly ancient stones are subject to transformation. The implications extend outward into planetary science. If interstellar objects can fracture in such unexpected ways, then the processes governing the evolution of small bodies must be revisited. This affects not only the study of alien systems, but also our own. Earth's history is deeply shaped by impacts from asteroids and comets, and the possibility that such bodies may behave unpredictably, splitting, shifting, or altering course, adds complexity to models of planetary defense. Though 3I Atlas itself posed no threat, its behavior is a reminder that bodies crossing through planetary neighborhoods cannot always be assumed to follow stable trajectories or remain intact. The split also intersects with the growing field of comparative planetology, which seeks to understand how different stellar systems produce similar or divergent outcomes. If 3I Atlas represents material from a system very unlike our own, its behavior may hint at processes foreign to the solar system. The fracture could be evidence of compositions or internal structures not represented in local samples. In this way, the object becomes not only an astronomical curiosity, but a window into the diversity of planetary systems across the Milky Way. There is also the question of how such events shape galactic history. When an interstellar body fractures, each piece continues on its own voyage, potentially entering different star systems in the distant future. Each fragment thus becomes a separate emissary, carrying the chemical fingerprints of its origin into new regions of the galaxy. The split of 3I Atlas, therefore, may have multiplied its influence, sending two separate messengers into the cosmic sea where once there was one. Over spans of billions of years, these fragments might collide with planets, moons, or other asteroids, leaving faint but enduring traces of their journey in new environments. For NASA, the practical challenges of observing both fragments were immense. Space-based instruments needed to adjust their targeting to track two faint points of light instead of one, while ground-based telescopes recalibrated their predictions to account for the shifting orbits. This required international coordination, as observatories across the globe contributed to the effort. The event underscored the collaborative nature of modern astronomy, where no single institution can capture the full picture of an unfolding cosmic drama. Harvard scientists, meanwhile, emphasized the interpretive challenges. Each dataset raised new questions. Why was the fracture line so clean? Why was there so little dust? Why did the fragments remain so coherent? In every answer lurked deeper uncertainty, a reminder of how poorly understood interstellar bodies truly are. Yet rather than discouraging researchers, this uncertainty fueled a sense of discovery. To be faced with an event that defied explanation was to be reminded of why science exists, to encounter the unknown, and wrestle with it until patterns begin to emerge. The public fascination with 3I Atlas only added to the momentum. News of its split spread quickly, drawing attention from those who rarely follow astronomy. The image of a lone traveler dividing itself against the backdrop of the stars captured imaginations, prompting speculation not only about natural causes, but also about the broader mysteries of the cosmos. While scientists dismissed more fanciful suggestions, such as artificial origins or alien engineering, the very fact that such ideas arose showed how deeply the event resonated with people's sense of wonder. For educators and communicators of science, 3I Atlas provided a fresh story to inspire interest in space. Here was a concrete example of how the universe still surprises, how real discoveries can rival or surpass the wildest of fiction. Students learning about planetary science could point to a contemporary event where the textbooks offered no ready answers, highlighting the living, evolving nature of scientific inquiry. One of the most intriguing aspects of the event is how it may influence the design of future missions. Before 3I Atlas, the notion of sending spacecraft to intercept interstellar objects was ambitious but narrowly defined. Target the visitor, sample it, study it, and perhaps return data or material. Now, the recognition that such bodies may split introduces new complexities. Missions must be prepared for unexpected changes in the target, including division into multiple bodies or sudden alterations in trajectory. Spacecraft may need adaptive strategies, capable of tracking not one but several objects simultaneously. The split also has implications for long-term projects such as Breakthrough Starshot, which aim to send probes to other star systems. If interstellar bodies are dynamic, not static, then the interstellar medium itself is more active and unpredictable than once believed. Probes traveling through it will need to account for a richer range of encounters and challenges. In this way, the fracture of 3I Atlas is not just a curiosity of the present, but a lesson for the future of interstellar exploration. Even within the framework of cosmochemistry, the event is groundbreaking. By exposing fresh interior surfaces, the split may allow scientists to study the pristine material hidden beneath the crust. Spectroscopic analysis of light reflecting off the fragments could reveal differences between the surfaces, offering a glimpse of compositional layering or gradients within the body. Such data would be impossible to acquire from a single intact object, making the fracture a kind of accidental experiment provided by nature itself. Harvard researchers noted subtle differences in coloration between the fragments, suggesting that each piece may expose different material. If confirmed, this could revolutionize understanding of how such objects form and evolve. Perhaps 3I Atlas preserves records of distinct environments from its original system. Different layers of accretion, different histories of exposure. In splitting, it may have laid bare secrets that no spacecraft could otherwise access. As weeks passed after the event, astronomers found themselves speaking of 3I Atlas in new terms. It was no longer a singular visitor, but a pair. A binary story unfolding across the sky. The language used to describe it shifted from object to system, from solitary traveler to divided family. This linguistic change reflected the deeper scientific transformation. What was once a straightforward encounter had become a complex puzzle with multiple moving parts. As humanity gazes toward the heavens, 3I Atlas drifts further into the night, its two fragments carrying with them the mystery of their division. The story is unfinished, yet even in its incompleteness, it enriches the understanding of the cosmos. It is a story of transformation, of quiet rupture, of a moment when the universe reminded us once more that it is alive with processes we are only beginning to perceive. In this sense, the split is not a conclusion but a threshold. Beyond it lies the promise of new theories, new missions, new ways of thinking about how the galaxy shares its secrets. 3. Atlas has become more than a visitor. It is a teacher, a challenger, a herald of questions that will occupy scientists for generations. Its division into two is both a physical event and a metaphorical one. A division in certainty, a split in the boundaries of human knowledge, opening space for new understanding to take root. When the confirmation arrived that 3I Atlas had cleaved into two separate fragments, it not only stunned the scientific community, but also forced a wider rethinking of how interstellar events are woven into the tapestry of cosmic evolution. The breakage, though subtle and not accompanied by dramatic jets of material, represented a phenomenon with implications far beyond its immediate observation. To grasp the full meaning of this occurrence, it is useful to stretch the imagination across scales, from the intimate structure of rocks and ice to the grand architecture of galaxies, because each scale offers a perspective that deepens the significance of what Harvard and NASA had confirmed. One of the immediate consequences was a renewed interest in the question of longevity. Interstellar travelers like 3I Atlas are presumed to be extraordinarily old, forged billions of years ago in star-forming regions and flung into space by gravitational disturbances or planetary migrations. To survive for such timescales, these bodies must possess some measure of durability. Yet the fact that 3I Atlas fractured raises the unsettling possibility that many interstellar objects may be ticking clocks, carrying structural instabilities that eventually find expression. If these instabilities can be triggered by relatively modest encounters with stars, it suggests that most of these bodies may not last forever, but instead undergo periodic transformations throughout their lifetimes. This reframes the galaxy as a place where interstellar debris is in constant flux. Instead of seeing space as littered with stable, long-enduring fragments, we may need to envision it as a dynamic environment where bodies fracture, reassemble, and fragment again. Over millions of years, a single object could become many, its identity dispersed into multiple travelers. The splitting of 3I Atlas is therefore a reminder that the galaxy's inventory of small bodies is not static, but perpetually renewed through subtle processes of change. From an observational standpoint, this realization is both a challenge and an opportunity. On one hand, it means that the cataloging of interstellar visitors will always be provisional. What is seen at one time may not be what exists at another. On the other, it provides astronomers with a natural laboratory to witness processes that are otherwise invisible. The fracture of 3I Atlas is essentially a glimpse into the life cycle of interstellar material, an episode that would otherwise pass unrecorded across the vast reaches of space. The event also casts light on the mechanics of gravitational encounters. While comets and asteroids in the solar system have been observed breaking under the stress of close planetary passes, 3I Atlas did not approach any body closely enough for a dramatic tidal disruption. This implies that even subtle gradients in gravitational fields stretched across millions of kilometers may accumulate effects strong enough to destabilize a fragile interstellar object. Such a scenario challenges existing models of orbital dynamics, suggesting that low-level forces once considered negligible may play larger roles in shaping cosmic debris than previously understood. This has a direct bearing on the modeling of near-Earth objects. If modest gravitational stresses can produce dramatic consequences over long durations, then predictions of how certain asteroids or comets might behave during flybys of planets may need to be revisited. 3I Atlas offers an example of how quiet interactions with gravity can culminate in surprising physical outcomes, a lesson that planetary defense initiatives cannot ignore. Another thread of interest lies in the thermodynamics of interstellar travel. As 3I Atlas drifted for billions of years through the cold of interstellar space, it would have equilibrated to temperatures just a few degrees above absolute zero. Entering the solar system introduced a shift, though still relatively mild compared to bodies that plunge close to the sun. Yet even this small increase in warmth might have awakened stresses frozen into its structure. If temperature changes on such modest scales can act as catalysts for breakage, then interstellar objects may be far more thermally sensitive than scientists assumed. This sensitivity suggests a fragile balance between rigidity and vulnerability. On the surface, an interstellar body may appear solid and inert, but internally it may be riddled with microfractures, compositional layering, and trapped volatiles. Such hidden complexities transform them from simple rocks into intricate systems of physical interactions. The splitting of 3I Atlas may be the visible expression of processes long underway, invisible until the solar system's environment tipped the balance. Astronomers also considered the role of cosmic radiation. Interstellar space is permeated with high-energy particles that bombard matter relentlessly. Over immense spans of time, this radiation can alter chemical bonds, induce structural weaknesses, and create fragile zones within a body's matrix. If 3I Atlas had spent eons exposed to such bombardment, its fracture might be seen as the long-delayed consequence of radiation damage. In this sense, the event connects with the broader field of space weathering, a subject usually applied to surfaces of moons and asteroids, but now relevant to the deep interiors of interstellar wanderers. For researchers in astrobiology, the split of 3I Atlas sparked provocative lines of thought. If interstellar bodies are capable of change, then they may be more effective couriers of organic molecules than previously considered. A fracture exposes new surfaces, providing fresh canvases for chemical reactions triggered by radiation or solar exposure. It also increases the surface area available to release materials into space. In this way, the splitting of an interstellar object may enhance its role as a distributor of complex molecules across star systems, boosting the chances of seeding life-friendly chemistry in distant worlds. The event may also influence how scientists interpret meteorites and micrometeorites found on Earth. If fragments of interstellar bodies occasionally enter the solar system and split, some of their debris may find its way into Earth's atmosphere, mingling with local material. Distinguishing such interstellar grains has always been challenging, but the behavior of 3I Atlas suggests that there may be more of this material reaching us than previously recognized, delivered not as intact bodies but as smaller shards born of fractures. Culturally, the split resonates with humanity's instinct to see meaning in division. A singular traveler becoming two evokes ancient archetypes, the splitting of primordial entities in creation myths, the concept of twins or dualities shaping destinies. While science maintains a clear-eyed approach, the symbolic undertones cannot be ignored. They reveal how events in the heavens are always interpreted through the lens of human imagination, binding empirical discovery to deeper cultural narratives. In classrooms, museums, and public discussions, the story of 3I Atlas will serve as a bridge between the rigor of science and the poetry of wonder. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas splitting? We want to hear from you. Thank you for watching, and see you next time.